I'm doing badly. Ah, that's better, isn't it? Yeah, I thought it wasn't working, but wasn't quite sure. Anyway, good morning again. So 45 minutes, cover the single sign-on options, and this is for our users who we've taken from on-premise and we put into Azure AD. So that's what I want to look at here. And 2 weeks ago at Ignite, a couple of components went GA, and I'll talk about those in quite a lot of detail. So first of all, I want to look at the different sign-in mechanisms. I couldn't leave this session without just briefly mentioning Windows 10 and Windows 10 options, but my main focus is on the first portion of that there. So starting off, if we wanted to get our on-premise AD users to be using the benefits of Azure AD, we've somehow got to get them up into the cloud. And the way we do that, of course, these days is using Azure AD Connect. So we take our users, we take our groups, we take our devices, and we can take them into the cloud. Equally well, there will be things that we want to bring back from the cloud. So devices that are registered directly in the cloud, groups that are created in the cloud, and things like right backing of passwords. So we're doing maybe the self-service password reset in the cloud. We want that information written back. Even if we're not doing self-service reset, we could have an administrator resetting a password in the cloud, and we want that to go back. Azure AD Connect is the way to go. And at the moment, Azure AD Connect is Azure AD Connect, and I put ++ on there, because it's a synchronization engine, plus we do a lot of other configuration through it. And of course, user sign-in is where we do that configuration. So the first thing there is password synchronization. And this is the most horrendously defined name, password synchronization. When Microsoft first came up with this, people thought, password synchronization, what do they mean? They're taking our passwords and they're syncing them into the cloud? And chief security officers, you could see them, they were pulling their hair out with absolute trepidation. And password synchronization was pretty much banned in an awful lot of companies. We should be referring to it as password hash synchronization. And I'm going to reclassify that by actually showing you what goes on under the hood. We then got pass-through authentication, which is new. That went GA 2 weeks ago, so into general availability, and that's referred to as PTA. And then we've got federation with ADFS, and a lot of the drivers towards federation with ADFS were the chief security officer saying, no way are you putting my passwords up there. Equally well, people wanted single sign-on. And then we've also got seamless SSO, and we need to find out what seamless SSO is, because that, again, went GA 2 weeks ago. We've got the one there, do not configure, and do not configure is where you've got some other mechanism for authenticating your users, and other mechanism would be a third-party federated solution of some kind. So, on-premise users signing into Azure AD. First option is we can do password hash synchronization, and there we are actually validating the user's password against the password actually held in Azure AD. But of course, it's not actually the password, it's a special hash of it, and I'll come back to that. The next one is pass-through authentication. And now what we do is in the cloud, we gather the username and the password from the user. So up pops the login. We actually gather that information, and then we pass that information to on-prem. And on-prem, we're running what we call an auth-n agent. And I'll talk about the agents and how exactly they work as we go through it. So now you're passing the username and the password down to on-prem, and you're validating that username and that password directly against the on-premise AD. And then the one that became very popular for a lot of users, actually, quick show of hands, how many are using federation with ADFS? Okay, that's very close to 50% of the audience, okay? This became very popular, and here we enter our username, all right? We don't actually have to enter our username. We can use things called domain hints, but we enter our username. It says, federated user. And what it does is it redirects that user down to the on-premise ADFS server, okay? This is the one I want to start with and just set the scene on looking at how this works in a little bit more detail. And then we'll get into all the detail of pass-through and pass-hash synchronization. And then, of course, we'll get into the detail of seamless single sign-on. But starting here, if we look at federation, we come against our application, and our application could be the My Apps portal, okay? And this app says, you're not authenticated. And what it will be looking for to check if you're authenticated is probably a cookie. And if you've got no cookie, it's going to say, you're not authenticated, go to the security token service I trust, which in this particular example is Azure AD. We end up at the security token service. Next job is, this guy needs to know who you are to know what type of authentication that should be used. So we do a thing called home realm discovery. And the home realm discovery could be that we put the username in. All right? Or it could be we've actually used a domain hint to actually automate that home realm discovery. And having done the home realm discovery, it says, federated user, and sends the user off to their ADFS server for their organization. And depending as to whether you're coming out from the internet and you're hitting the front-end proxy or you're going directly to the ADFS server, depends exactly how authentication happens. If you're going to the front-end proxy, you're going to have to supply username and password because it's going to be into a form. But if you're going directly to the ADFS server and you are joined to the corporate network and you have access to a domain controller, you can just get a Kerberos session ticket and pass it straight to the ADFS server, so seamless single sign-on, which is a reason a lot of people went for the ADFS solution. But nevertheless, we authenticate the user, we pass back a security token, and on that security token, that's been issued by the ADFS server. It means nothing to the app. What it means is something, it's a contract between your ADFS and Azure AD. So we pass it back, that gets processed, and then it generates a token for the app. Having generated the token for the app, we're authenticated. And the app, if you want to, can retrieve information from Azure AD, in which case we need to make sure everything's synchronized up, all the attributes we want it to be able to retrieve. And then finally, we return a page and a cookie. And that's the process we went through. Why did we do it? Well, number one, where is our password? It's on-prem, so nothing's gone up to the cloud in terms of password. And secondly, SSO worked with it if we went directly to the ADFS server. The cost is that we need quite an infrastructure to support it. We need at least 2 ADFS servers, all right, to give us our availability. We're going to need load balancers, and then we need if we're going to come in from the internet, we need a proxy in front of there, and ADFS proxy was done through the web application proxy. However, last week or 2 weeks ago, it was announced support for F5. So F5 is now fully supported as the proxy for ADFS. But there's quite a cost involved in doing this. So the question is to federate or not to federate. So federation gives you SSO via on-premise AD credentials, all right, which was a big driver towards that. And you get the seamless authentication to ADFS, provided you can get a Kerberos ticket, so you're within the corporate network. This functionality is now supported through seamless SSO and PTA, pass-through authentication. All right, seamless SSO will give you the SSO experience, and PTA allows the password to remain on premises. Password remain on premises, yep, that's PTA. On-premise authentication policies. So one of the drivers I've seen ADFS being used for, in some countries, you absolutely have to have log-on hours. All right? And for log-on hours, you need to have ADFS so that log-on hours could be checked against the on-prem AD. Well, that's now supported via PTA, so pass-through authentication. On-premise authentication method in terms of multi-factor If you've got your own on-premise MFA solution and you want to stick with it, then you still need ADFS. There's no other way of dealing with it. So we need to leave it with ADFS. Conditional access via ADFS. If you'd asked me probably 6 to 8 months ago, where do I get the best conditional access policy? I would have said ADFS. Now, though, the best conditional access policy is coming from Azure AD. So, yes, it was a driver, but actually the capabilities and much more than it can give you from on-prem is handled through Azure AD. Federation requires you need on-prem ADFS infrastructure with high availability. So, you know, a minimum of 2 ADFS servers, a minimum of 2, proxies. You want high availability for your company's internet connection. If you want your remote workers to carry on working, if something happens, if they're remote, they need to get to your on-prem ADFS server to authenticate. So high availability of that, or you need a second solution, as in putting ADFS in the cloud as well. So you've got it on-prem in the cloud, and DC in the cloud, multiple ADFS servers in the cloud, and it gets, again, expensive and difficult to maintain. And you also need planned recovery if ADFS becomes unavailable. How do we get our users logging in? Some more facts. Federation may require that you do manual certificate rollover. It depends how you've got ADFS configured. Federation doesn't give you cloud authentication scalability. If you use PTA, you don't have to worry about scalability. It's there. It's built in. The other thing is we're putting all our eggs in one basket. So we're moving our identities up into the Azure AD, maybe, and we're now reaching out to lots and lots and lots of applications. We've got to make sure that one basket is well protected. And one of the ways of protecting it is through identity protection in Azure AD. But you need a P2 license for that. But if you're not looking at identity protection, one of the takeaways I say definitely have a look at what the capabilities are. If we go for password hash synchronization and PTA, you've got cloud authentication, so the authentication is done in the cloud. All right? You've also got cloud scalability, and you've got identity protection. So now identity protection is looking at the users, and they can identity protection will flag a user at risk. Just an example is unreasonable travel. So if someone logs in New York, and then in London, and then in Dubai within 5 minutes of each other, that's considered as potentially unreasonable. Potentially, because it could be completely valid, because you might have VPN'd into 3 different offices. All right? However, that gets flagged. Equally well, if your username and password appears on the dark web, that will get flagged. That's considered high risk. All right? And then PTA gives you what we do with PTA. It's simple deployment of the agents. We need a number of agents. We'll come to that in a second. We've got automatic updating involved as well, so it handles that. It does automatic certificate rollover, so you don't even have to think about certificate. What you do need, though, is you need high availability of the company's internet connection. Because with PTA running, right, it expects to be able to pass those credentials down to on-prem. And today, at this point in time, there is no automatic fallover to something else. All right? And in fact, if you can't get from your company's Azure AD Connect server back to the Azure AD portal, you can't turn PTA off. All right? So you either need to make PTA available in the cloud as well, which requires a DC in the cloud and the PTA agent in the cloud, or if you do need to turn it off today, all right, you can do a support call, and they'll turn it off, and you can fall back to password hash synchronization. But just be aware of that. It is something that is being addressed. It's on the roadmap. But right today, you cannot disable it if you can't connect from your Azure AD on-prem, Azure AD Connect, to the cloud. Okay, password hash synchronization. I wanted to cover this because this is something that a lot of people just threw out because it was called password synchronization and it just wasn't trusted. What actually happens is, on-prem, you have your password, which is held as an MD4 hash of the password. Okay, so your password isn't held on-prem actually in clear text or anything like that. It's an MD4 hash. Azure AD Connect comes into play, and what it does is it just does through the standard replication. This is AD replication. It requests the Unicode password attribute. And what actually happens at that point is that you need the correct permissions in the directory to be able to pull that. It will then take the MD4 with a salt and an MD5 hash of the RPC session key. It encrypts it. Right? It then passes it to Azure AD Connect. Azure AD Connect is on-prem. Right? So it's on-prem, nothing's left the premises. The next thing that happens is this guy gets the MD4 back, right? Having got the MD4 back, it expands it, it salts it, and then it puts it through 1,000 iterations of HMAC SHA-256, right? And then it sends it up, and that's what gets stored, okay? So in the very, very unlikely scenario where Microsoft gets its database stolen, right, a rainbow attack is going to be useless because it's salted, the hashes are salted, and computationally it's extremely difficult to do a brute force attack because you've gone through 1,000 iterations of HMAC 256. So if this got stolen, it's almost impossible to reverse engineer it to get a password. I say almost impossible because if you had the most amazing computation available, then we could get it back. But it's gone through this 1,000 iteration. Okay, you might wonder, okay, well that's up there. How do we actually authenticate a user? Well, our user supplies, they supply obviously their username, their password, and then it gets processed. So it gets processed with the MD4, and then it gets salted, and then it goes through the password-based key derivative function with HMAC SHA-256, and if that matches that, then you're in. Okay, so really, password hash synchronization is pretty safe. The on-premise password complexity applies to synchronized users because where does the password get changed? It gets changed on-premise. However, it's possible for an administrator to change the cloud password. So you could have an on-premise password and the admin in the cloud using some PowerShell changes the password. So you have a different, it shouldn't happen, but it's possible. All right? And then that password in the cloud is going to be different to the on-prem until someone changes the on-prem and that gets synchronized up. An account lockout of an on-premise AD can still be active in the cloud. And the cloud password for a password hash sync user is set to never expire. If you disable the on-prem AD account, right, that fact that it's been disabled needs to replicate into the cloud. And that can take 30 mins, worst case, right, which is the synchronization delay. Okay. And then what a lot of people have done is they've got password hash synchronization as a fallback. If federation fails, they can switch back to password hash synchronization. Okay, so how many of you who've got ADFS also have password hash synchronization enabled? Wow, that's really few. Okay, that was just 3 people. Normally, what I've seen done, which is very naughty, I've seen password hash synchronization enabled. The chief security officer has said, no way you putting my passwords up there. So they deploy ADFS, and then someone says, hey, what about the fallback? Let's have password hash synchronization on as well. Which, of course, you could it's probably a sackable offense, but anyway. Okay, let's do a quick demo on this. This is where we've got the password hash synchronization going, and so we're going to start off. I'm going to have a look in the portal first of all at Azure AD Connect, and what this is showing me is that, and what I'm going to do is I will. Oh, well, I was hoping to zoom it, but its zooming is failing on me. It's very weird. Okay, so it's saying user sign-in, it's saying federation disabled, seamless single sign-on disabled, and pass-through authentication is disabled. Okay, what it doesn't show is that I've got a password hash synchronization enabled. It doesn't show it in the portal at the moment. Okay, so I'm going to go to an application I have in here. I'm signing in with Hybrid Flow. This is the test harness application I have. And I'm being prompted for credentials. I'm putting in my password credentials there, and I've signed in. Okay, this is actually a modern auth app. It's got the ID token in it and all sorts of other things, and I'd love to spend time going through all of that with you, but certainly not in this session. So we'll close that off, and then what I want to do is just go over to my DC, and I'm going to disable the account. Okay, so I've disabled the account on the DC. I'm now back. I'm just going to go to a Windows Auth app just to prove that the account is disabled. And so I'm being prompted for credentials directly by my Windows Auth app, and put in my credentials, and this, if the account's disabled, should fail, which it has. Okay, let's go back to my claims aware application, and let's see what happens there. So we go to the Claims Aware app, and I go and sign in with Hybrid Flow, and let's have a look. Okay, success. And the reason we got success is the account logout has not synchronized, and we're going to have to wait 30 minutes for that to happen. So we'll close that for the moment, and let's just go to my server where I've got Azure AD Connect running. Here, I need to supply some credentials to change the user sign-in, and I'm going to go in with my Azure AD admin credentials. So I have a user. I got some very, very strange domain names here, and we actually run a masterclass where everyone has their own domain, so we need to differentiate them, and that's what the 5 is doing, 5, 6, etc. And signing in there. And then I'm going to choose, I'm currently using password synchronization, and what I want to do is choose pass-through authentication, and I'm also going to enable single sign-on. So pass-through authentication, single sign-on enabled. Next on there, and I'm now being prompted for some credentials here, and what it's saying is it wants me to enter domain administrator account. You don't actually need a domain administrator account in here. What we need is an account that is capable of creating and managing a computer object. And this is to do with the seamless SSO. And I will come back on that very shortly. So next on there, it's ready to configure. We should get a check screen any second. And then what we'll do is we'll leave that cooking. Okay, so let's get that configuring. And I'm going to leave that cooking in the background. So let's have a look at pass-through authentication. So here, we're gathering the username and password in the cloud, and I'm going to pass it down to on-prem. So let's see how that works. Well, number one, we need a connector to go to on-prem. And this guy over here, this is an Auth-N agent. Our first agent runs on Azure AD Connect. It always runs on Azure AD Connect. And you notice there's a service, and there's an there's an updater service, and there's the agent service. This is actually built on the Azure AD application proxy connector. All right? And they only recently renamed these services. So there's a compatibility issue of running the app proxy and this guy on the same server. Now they've renamed the server, you can run them both. Okay. What he does is he makes an outbound connection up into Azure AD. Needs port 80 to validate as outbound. He needs to be able to validate certificate. He also needs port 443, right, to do the outbound HTTPS connection. All comms is done through mutually authenticated HTTPS. We'll see how that works in a second. And you need, if you want fault tolerance, you need 3 agents. because these agents automatically update themselves. And while one is updating, it's going to be offline. So what we'll end up with, if we don't have 3 agents, we'd end up with 1 agent, which is a single point of failure. All right, so we have 2 agents, and then running, so we need 3 in total to allow the update service to shut 1 down and still give us our fault tolerance. Okay, how's it work? So installation time, what's going to happen is the very first Auth-N agent, which goes on Azure AD Connect, what it will do is it will generate a key pair and then a certificate request through to Azure AD. And that certificate request is actually authenticated with a global administrator account, right, with the token of the global administrator account. So now what we're doing is we're passing the certificate request and the public key. The public key is stored in the cloud, right, and we get the certificate generated, which then gets sent back over here, and what we do is we marry the key pair back with the certificate. So now on-prem, we have a certificate with a private key. The public part of that certificate is sitting in the cloud. And then each agent, so we have multiple agents, each agent has a unique certificate. You don't have to worry about certificate rollover, it's all handled for you. So periodically these certificates get rolled. And then when we have PTA in action, what actually happens now, we have our Auth-N agent over the far end, and when that fires up, what he does, he says, okay, I'm going to connect up to Azure AD. We're now going to do mutual authentication, because I have a certificate, I can do that. So we've authenticated, and then what will happen is Azure AD passes down a key which will allow the agent to access a service bus. So now the agent connects up to a service bus and it's effectively listening on this service bus. Okay. Next job, user comes to log in. We gather the credentials from the user and Azure AD will detect that this user is enabled for PTA, as in pass-through authentication. So what will happen now is we will actually as it's enabled for pass-through authentication, we'll take the password and we'll encrypt it with the Auth-N agent's key. And we'll do that for each Auth-N agent. And then we'll put the username and the encrypted password into the service bus queue. Right? That guy's listening to the service bus queue. So now he takes the username and password out. He decrypts the password. Only he can decrypt the password because only he has the private key. All right? So he decrypts the password and then just does a standard Win32 logon user API call against on-prem AD. All right? That will succeed or it will fail. And what we do is we take the results. If it's success, we just pass it back to Azure AD and say, yep, logged in. If the account's locked out, we immediately pass that back, account's locked out. And then we can take the appropriate action up in the cloud. Okay, so that's the mechanism that and how it actually operates. And as I say, we can hang. This is encrypting here for each Auth-N agent. So the Auth-N agents hang on the queue and take out their appropriate information. Account lockout. This is something we have to deal with because now we're gathering username and password in the cloud and we're passing it through to on-prem. So we could do an attack and actually force account lockout on premises. So we need to protect against that. And in the cloud, we actually have an Azure AD account lockout, and the default is 10 failed attempts, and it locks you out for 60 seconds. If you do it again, it locks you out for longer. But it's a very intelligent lockout because what it's looking for is it's looking for, if you're coming from your normal IP address to log in, it will say, actually, do you know what? That's probably okay. So it will lock out from other addresses, all right, but not necessarily lock out straight away from your own IP that you've been using previously. So it's running AI and looking at behaviors. So it will change things. So pass sign-in behavior, user device, browser, IP address, etc. And it automatically adjusts. Now, those are the defaults. What we've got to do is we've got to make sure that Azure AD locks out before on-prem locks out, right? Because otherwise we've lost the benefit. So you need to change. So the smart lockout threshold must be at least the on-prem AD lockout threshold. The recommendation, though, is to make it 2 or 3 times higher. All right? The reason being, of course, because it's the way the lockout's handled. There's a lockout counter per data center, so it's not absolutely precise. Plus, we've got the algorithms changing things, so the value could shift and be automatically. Now, you might say, well, actually, I'm not happy with those default settings. So how do you change the default settings? And that's something that's new, is the ability to change the lockout settings in Azure AD. Now, this PTA and lockout is available to all versions of Azure AD. The free version, the Office 365 version, the P1 version. However, today, if you want to change the smart lockout time, you need a P2 license. But of course, only one person needs to change that smart lockout time. But to be able to do it, you need to call into the Graph API. The administrator will need a P2 license to be able to do that. And what you've got is, you've got a template where you change the lockout duration in seconds, the lockout threshold. It also has the ability to have you to set up a banned password list. So if you don't like some passwords to be used in your organization, you can now add a banned password list. To make that change, use Graph. So using the Graph API, plus you need a P2 license to be able to do it. You need administrative capabilities within Azure AD, plus the P2 license. So pass-through authentication, the facts. So no on-premise passwords in the cloud. All right, so if your chief security officer says, we can't have passwords, you've got a solution now. All on-premise password policies are operational. So if you have things like, log-on hours, that is all in effect. Account lockout and disable immediately takes into effect, because why? Because we're actually authenticating against on-prem AD. Okay, it does not support on-prem MFA. All right, so it does support Azure AD MFA. So if you want on-prem MFA and you've got an on-prem MFA solution, you have to use ADFS. It works with alternate IDs if you're using IDs. It does not provide SSO. To get SSO working, you require to add on seamless SSO, and it does need high availability of your company's internet connection if you want remote users to be able to log in. So if you lose your corporate internet connection, you've got remote users and they're using this, they're not going to be able to log in. And today, just remember, if you want to turn it off, you have to do a support call. You can have on PTA and seamless a password hash synchronization, but you can't turn off PTA today. It also doesn't support legacy authentication. So if you're using legacy authentication, so example is Office 2010 in there. Okay, let's just do a quick pass-through authentication demo. And what I'm going to do here is I'm going to, we got the configuration of that complete, so we'll exit from there. So we should be using pass-through authentication. Let's go down into the portal, and let's do a refresh on here. Okay, so federation disabled, seamless SSO enabled, pass-through authentication enabled. Okay, so that's taken okay. Let's try it out, and let's see, we click on pass-through authentication. What we can see in there is it's saying there's an authn agent running on this particular server at that particular IP, and its status is currently active. Okay, so let's go and have a look now at the effect of this. So we're going to go into my Harness app or my test app, signing in with hybrid flow, and we're going to supply the password and the account's locked out. Well, you could say to me, yeah, but it must have replicated by now. All right, so we were using hash synchronization before. It could have replicated. Let's have a look though. Let's just see if this actually works. Let's go across to my DC and let's re-enable the account. So enable the account, and let's go back again and put in our details in here. And that's straight in. So we've gone straight in there, and that's pretty much it for pass-through authentication. So what we need to do is add to that is the seamless SSO capability. Okay, so in terms of seamless SSO, it works with pass-through authentication, or it works with password hash synchronization. Users only need to type their name, and immediately, having typed your name, it detects, it says seamless SSO enabled. In fact, if you've got applications that can use domain hints, as in supplying the domain the user is from, right, you will not even be prompted for a username. It will go straight into the SSO mechanism. There are more and more apps that are capable of doing this. Example, myapps.microsoft.com. If you put in there /your domain afterwards, so example.com, what it will do is it will create a domain hint. So you will actually get seamless SSO with no prompt for a user name. So that's just automatically added there. You've got support for Windows 7 and above. Edge currently is not supported. They're still working on support for that. The machine must be able to access a DC because of the way this mechanism actually works. It authenticates to Azure AD with a Kerberos token. So to get a Kerberos token, we must be able to access a DC. It supports alternate ID again, and it supports sort of most browsers, most OSs. It also has Safari and Mac support in there as well. So how does it work? So we come and we install. And the first thing it does is it creates a computer account object. You remember I was prompted for credentials? Those credentials were to create this computer account object. And what happens is there's a key that is deployed onto this computer account object, and it's used as the Kerberos key. User hits I'll come back to that in a second. User hits an app, and the app says, you're not authenticated, all right, and this is a claims-aware app, and sends it up to Azure AD to get a token for this app, right? If SSO is enabled, what it will do is it will send down some JavaScript to test this device to see if it's properly configured. If it's properly configured, the next thing it does, and to be properly configured, what we need is a couple of URLs in the intranet zone. If they're in there, the next thing that happens is we get back a 401. And 401 says not authenticated, but I do Windows authentication, all right? And this guy says, he does Windows authentication. Fantastic. What I'll do is I will go to my KDC and say, please, can I have a Kerberos token for this endpoint? Where's that endpoint? It's sitting in this computer object set up by an SPN that's automatically put there. All right? So this guy says, absolutely, I can give you a Kerberos token for the endpoint you're asking for. In which case, we get back the Kerberos token, and then we pass it back to the endpoint. Now we're authenticating the endpoint. How does Azure AD validate that token? Well, it has the key that was used to encrypt the token. It's the same key. The token that encrypts it is this effectively, that computer account is deemed to be running this service, and therefore the service token or the session ticket is encrypted with that key. This guy has got the key as well, can decrypt, and then we get back a claims token. This time we pass it back, and it's all worked beautifully. So that's the basic mechanism. Seamless SSO will work with PTA or PHS, and if the user is connected, all right, to an on-prem AD, the Kerberos token issuing will succeed. If they're not connected, or they can't get access, or the configuration of the browser is slightly wrong, maybe we haven't added those into the zone, what it will do is it will just simply fall back to using pass-through authentication or password hash synchronization. So you use it in combination with PHS or PTA. Kerberos key, today it doesn't automatically roll over. So the recommendation is for you to roll that Kerberos key, the one that's shared between Azure AD and that computer account object. And I've put a link in there for you to go and find out how you roll it. It's a very simple process, but you do have to do it. It's on the roadmap to automatically roll. Okay, let's just have a very, very quick look at Seamless SSO in action. And so what we're going to do is we've got Seamless SSO running. If I use Fiddler in here, just to capture a couple of things, and I'm going to go over to OIDC. I'm using domain hints here. This particular example has domain hints, and nothing happens at the moment. It's still asking me for my username. The reason being, Seamless SSO is enabled, but I haven't configured the browser yet to support it. Okay, so if we actually have a look, the first thing is I hit the app. I then go sent up to Azure AD. Let's just grab this string here, and let's just pop that into Notepad. And this is the authentication string, and what it's got in here is the fact that I'm using a domain hint. So my domain hint, and it's telling the system what domain I'm coming from. So there's the domain hint in there. So that's going up, and then what I've got is, because I've got Seamless SSO on, I'm going to autologon.microsoftazure-sso.com. And what that's doing is pushing a whole bunch of JavaScript into my browser, which is testing to see if the browser's configured properly. And the problem is, at the moment, it's not configured properly. So if we look at that, if we just check, we get a 200 OK. There's the JavaScript coming down, and it's decided my browser is not configured, so we don't even attempt SSO anymore. So what we can do is just minimize that for a second, and we can go in and go to Internet Options on here, Security, and I'm going to add into my local intranet, I'm going to add in my Seamless SSO settings. So I need to add this guy in. And you may wonder why there are two. Well, one is an alias. They're C-named, basically. And one is the name, and one is an alias. And we need both of those in there. Close that off. And now let's experience Seamless SSO. So if we go back to the browser, to Fiddler, just clear that. And come in and let's do it with domain hints, and no prompt at all. Okay, and if we doing that, we're now in with absolutely no prompt. We're not being asked for a username, and we've got SSO, so it gives us the SSO capability. Just one page on Windows 10 before we finish, and if you're not familiar with Windows 10 and Azure AD, what we can do is we can do what's now called, it's been renamed, it was called all sorts of things as a domain join ++. It's now called hybrid Azure AD join. And I can join my computer on-prem and into the Azure cloud at the same time. And when I log in, what I will get is a Kerberos token for on-prem access, and I will get a primary refresh token, which will now allow me access to all of the Azure protected resources. So I will have true single sign-on on-prem and also into Azure. So I just wanted to mention that was there, and conditional access policies based on users' devices, and also the ability to do Windows Hello as well. In terms of a summary, I've built this table, which obviously I'm not going to go through, but it's a really good discussion table if you're now talking to someone about whether you should go for PTA with SSO, PHS, or ADFS. So that's available as a table when you get the slides. And in terms of recommendations, the recommendation now is not to go down the ADFS route, is to look at using PTA or PHS. All right, and if you've got ADFS, stick with it. But the recommendation is to start, if you've got ADFS and you've got claims-aware application, start migrating those claims-aware applications away from ADFS and register them in Azure AD. All right, but don't necessarily just chuck your ADFS out, but, you know, upgrade time, maybe we don't want it anymore. And of course, turn on seamless SSO because it doesn't cost you anything and it really enhances the user experience. Okay, so I've run 1 minute over time, so apologies for that. But as I say, it was hard work to get it in the 45 minutes. Lots more I could talk about, but thanks for coming to the session. Thank you.